Hey guys, so in this lesson we're going to learn about intermolecular forces and how that affects properties of different types of compounds, namely covalent compounds. But we are going to also, this is sort of like a preview into the phase changes that we're also going to learn about in this unit and how one substance can phase change from a solid to a liquid to a gas and what's involved. Okay, so let's start with what intermolecular forces are. Well, intermolecular forces are not an actual chemical bond. These are attractive forces that are going to take one molecule and attract it to another molecule. Okay, so they don't have to be the same molecules, but to make life a little easier, we are going to just talk about one molecule attracting another like molecule. Okay, so notice that this dashed line, that dashed line is not a bond, it's the attractive force being illustrated. So when we have a chemical bond, that is an intramolecular force among the molecule itself. Whenever we have it between two molecules, that is an intermolecular force. It's a lot weaker than an actual bond, okay? Now, we're not going to quite get into this much detail, but we could also draw the structure and then show the polarity of bonds for the polar covalent bonds and show you where the positive end and the negative end is so you can understand the basis of the attraction. See how this one's positive and that one's negative? It just makes sense that a positive end of a molecule is going to attract to the negative end of another molecule, okay? So let's talk about this in a little bit more depth. There are three types of intermolecular forces, and we're going to take some notes in a little bit, but I just want to give a quick preview. So three types of intermolecular forces. This just talks about the difference between the two forces. These are not quite in order, okay? But the first type is a dipole force. That's going to be whenever you have opposite charges, but it is a polar covalent molecule. That's going to be a dipole force. We're going to call the ion dipole force a dispersion force, but that's when you have some type of ion. This can also happen with something that is not polar, and you have the attractive forces, and then we have hydrogen bonding, and hydrogen bonding occurs most commonly with water, and it's one end that is highly negative in polarity, attracting to the hydrogen specifically of another polar molecule, okay? So it also leads to the different structures of these types of molecules. If you have covalent, these have to do with the electrons around the nuclei and how they're being shared. Ionic, obviously there's a cation and an anion, and then metallic compounds. Okay, so don't stress over all the details. So we're going to fill this out in the next lesson, okay? Actually, my fault. We're going to go ahead and fill this out. So as we are looking at this, we're going to fill in some of these answers. For metallic compounds, those contain just metals. For example, you could have just sodium, you could have just copper, you could have just iron, etc. All of those are going to be metallic solids. And the type of bonding that occurs in here, you have the valence electrons, but the valence electrons are in a special formation. This formation in a form of and I'm going to write this in quotes, but this is the actual term. This is so ugly. A sea of electrons. So a sea of electrons just means they are collectively pulling all their electrons together, okay? I didn't use the word pull as because it's the sea, but anyway, if you think about water, everything that's in a pool just kind of stays together. That's what the sea of electrons does, and only metals can do this. If the electrons can travel, it can allow electricity to flow, so this is why metals have properties that non-metals don't have, okay? But that's the sea of electrons. Now, for ionic compounds, I'm actually going to make this a little I know this is huge, but I'm actually going to make this a little bit larger because I need to be able to like undo these little glitches that are happening and also write in different colors so all this doesn't run together. So that's a metallic compound. Just want you to recognize the difference. Then covalent compounds, we're going to have a couple of different types. One is a network solid. A network solid, these are going to happen whenever, what did I just say? Oh, anyway, these ionic compounds, not covalent, we're going to talk about ionic. These are with the typical ionic compounds that you're familiar with, like table salt, okay? Other chlorides like magnesium chloride, anything that contains a metal with a non-metal. It doesn't have to be a chloride. You could have like calcium oxide, and all of these form lattice structures, okay? So these lattice solids, these are going to be responsible for like sodium chloride. What shape is that? It's a cube. So whenever you break sodium chloride down into smaller pieces, it still holds that shape, okay? So network solids, my fault, this is the wrong part for me to write that down. So these are ionic compounds and they transfer electrons, okay? So they transfer electrons to make positive or negative ions that create the lattice, okay? All right, so a lattice is just an interconnected repeating units of the ions, okay? So now we're gonna move on to, I kept trying to talk about covalent compounds. So covalent compounds are the network solids. These are really rare. Some examples are carbon. Carbon can take on some unique different forms. We have in the form of graphite, but an even stronger form and even more rare is diamond. Okay, and then one other example besides carbon, we could see silicon dioxide, and that takes the form of sand or quartz, or even taking sand and blending that together at a high temperature makes glass. Okay, for the network covalent bonding, these are very strong, but because they're not ionic compounds, these are the covalent equivalent to, see this glitch, that drives me crazy. So the covalent equivalent to a lattice, which is only seen in ionic compounds, okay? So now this next part, we are going to focus a little bit more in another lesson on this, because this is the main part of this unit, okay? All right.